Hi, today I'm going to talk about resistors, specifically resistors in series and in parallel. But before I get to explaining those specifics, I just wanted to generally explain what a resistor was. So a resistor restricts the flow of current within a circuit, and current is just the flow of charge through a circuit. Specifically, resistors convert energy, and so usually that's through thermal energy or light energy, like specifically a light bulb is a certain kind of resistor. And so these diagrams right here show different circuits. This represents a battery, and then these two represent different kinds of resistors. This symbol represents just a normal resistor, and then this symbol represents specifically a light bulb. And so as the flow of current is flowing through a circuit, it will hit the resistor, which will then convert that electrical energy into a certain kind of energy, let's say thermal energy, and then it keeps going through until it reaches the other side of the battery. And the units of resistors are in ohms, and so this is represented by this omega sign. So now we're going to talk about resistors in series and resistors in parallel. So we'll start out with in series. So for resistors in series, they're generally used in low power circuits, and this is because the resistance is usually higher, which means the current is smaller according to Ohm's law. I don't know if you can see that, but if your resistance is higher, that means your current will need to be smaller in order to balance that out, which is why they're usually used in low powered circuits. The formula to calculate resistors in series is R total equals R1 plus R2 plus R3, however many resistors that you have in your circuit. So specifically with this circuit right here, you'll start out with your battery and move along, and you'll hit the first resistor, the second one, the third one, before you get back to the battery. And this is why that they're in series, is because you'll need to pass through each of those resistors before you get back to the battery. And this is why you'll just add them up all the way through the circuit. And it's also important to remember that your total resistance for resistors in series will always be greater than any of the individual resistors within that circuit. So in order to calculate this, you will have R total is equal to 3 plus 5 plus 2, just adding all of those up together. So your total resistance will be 10 ohms for this series circuit. For resistors in parallel, it's a little bit different. Usually resistors in parallel are used in high-powered circuits, and for the same reason, using the same equation for Ohm's law, usually the total resistance is smaller, which would mean that the current will have to be higher, which is why they're used in high-powered circuits. And so the formula that we use in order to calculate resistors in parallel is the inverse of 1 over R1 plus 1 over R2 plus 1 over R3, however many resistors you have. So specifically for this resistor, you only have 2, so we'll just put those in that equation. And so the reason why these are in parallel, differing from the in series, is because as you start at your battery and you go through, you'll hit this junction point where the current can either flow through this circuit right here in order to get back to the battery, or go through up here through this resistor. And so they'll have to hit the diverging point first before they converge and come back into the battery, which is why they're in parallel. Differing from the resistors in series, how the total resistance is greater, for resistors in parallel, the total resistance is always going to be lower than the smallest resistor. So let's say if this resistor right here was 2 ohms, then the total resistance would be less than 2 ohms. So if we were going to calculate the total resistance for this circuit, it would be R total is equal to 1 over 4 plus 1 over 4, and then the inverse of that And so 1/4 plus 1/4 is 2/4. So it would be 2/4 and the inverse of that, which would be equal to 4/2, which is equal to 2. So the total resistance for this circuit in parallel would be 2 ohms. Alright, so now that we've learned what to do with both resistors in series and in parallel, we have the tools to be able to simplify this circuit. Even though it looks pretty crazy, really we'll only be using these two formulas right here that we learned, and I put them up there for reference so we can use them while we solve this problem. So usually what I do is I try and look for the smallest parts of the big circuit to simplify first, and then slowly we can start simplifying it even more. So the first things that I see are both these circuits in parallel right there. And so what I would probably do is solve those first. So if we come down here, our R total will be equal to 1/8 plus 1/8, the inverse of that. And so that will be 2/8. The inverse of 2/8, which is 8/2, which is equal to 4. And so this little circuit right here is equal to 4 ohms. We'll do the same thing up here. So instead of 1/8, that will be 1/6 plus 1/6, which will be 2/6, and then 6/2 right here, which is equal to 3. So that means that this is equal to 3 ohms. So now that we've simplified those two, I probably would look at the things in series. So we can see that this right here is in series with each other, and this is in series as well. And so we can add 3 ohms plus 7 ohms, which is equal to 10 ohms. And then right here, 2 plus 8 ohms is also equal to 10 ohms. What I would probably do next after that is see that this whole thing right here, which is equal to 10 ohms, and this whole thing right here, which is also equal to 10 ohms, is in parallel with one another. So we can come back down to our work that we used previously down here and say 1/10 plus 1/10 is equal to 2/10. Inverse of that is 10/2, which is equal to 5. So this whole thing right here is equal to 5 ohms. So if we wanted to simplify this a little bit better so that we can visualize it better, if we redraw it, we'll still have this resistor right here and this resistor up here. But we'll also have one resistor on this side, and then, which is this whole thing right here, and then down here we'll have one resistor. So right here is equal to 2 ohms, this up here is equal to 3 ohms, this right here is equal to this whole thing, which we calculated as 5 ohms, and then down here we have 4 ohms. So as we can see in this circuit right here, everything is in series with one another because you hit each resistor as you go through the circuit before you get back to the battery, which means that you just add them together in series. So that means your R total will be equal to 2 plus 3 plus 5 plus 4, which is equal to 14 ohms. And so 14 ohms is the total resistance of this whole entire circuit.